Hi, in this video, I will be going through how many 10 problems from this assignment of 30, where basically you're going to review the concepts that you have studied this week on quadratic functions. As you can tell from the titles here, we will be practicing finding roots, but sometimes they will not be easily identifiable, so we might need to use Vertex. Your axis of symmetry in Vertex, again, you can see with Desmos, we're going to be using Desmos for those, if you'll look over here at the title. And then for 6 through 19, these are all about identifying particular characteristics of the graph. But I am going to have to show you some new things, including how to determine when a graph is increasing and decreasing, how to write those intervals. So I'll go over some of those examples. And I'll actually include that in the notes. And then here, finding extreme values, which are really just the max or min, but how to answer the question will be particularly new. And then 4, where we will practice finding the range. Remember, we've studied domain and range of a quadratic function. Domain is always negative infinity to positive infinity, but the range, lowest y to highest y, depends on whether the graph opens up or down. So I'm going to do 27 and 28, and you'll practice 29 and 30. My recommendation would be for this video that you can see that they're set up in like groups. So like 1 through 3 are about finding the roots from the vertex or the vertex with Desmos. So that means I'm going to do number 1 for you, and I recommend that you then pause the video and do numbers 2 and 3. Then go back to the video to hear me talk about number 4. Then go back and do 5 and 6, etc. Okay? So in this video, I will say, okay, please pause this video at this time and do the next set of problems. All right, so we're going to go ahead and take a look at number 1, and I'm going to open my screen because we don't need to take notes until we get down to increasing and decreasing intervals, unless you would just like to jot a few things down. On your notes, if you're listening, please go ahead and put today's date, which is 10/2/20, in the top right corner. Put 10/2/20 of your notes. So number 1, it says finding roots or vertex with Desmos. So it says find all the roots. Remember that roots is synonymous with the word x-intercepts or zeros. And you have to identify the vertex of the quadratic equation on the calculator. And then round all values to 3 decimal places if they are not integers, meaning positive or negative whole numbers. So notice it says using a calculator. We're actually going to use Desmos because Desmos is the tool that you actually use in your final exams for math for math 1, 2, and 3 when they're on when they're state exams. We do not have a state exam for math 2 this year. We are still using Desmos because it's an awesome calculator. So you're going to go to desmos.com. So my recommendation would be to open another tab, go to desmos.com, click Graph and Calculator. I'm going to show you a little trick that'll help you. Once you have that open, minimize. So up here in my top left corner, or you might in your top right, have a button where you minimize it like that. And then you're going to take this tab here, and I'm holding down my left key, and I'm simply dragging it out. So now I actually have my Desmos on one side and my graph and calculator on the other. So now I can see the equation that I need to type in. So I am going to, in Desmos, type in this equation. So you can use your keyboard, or you can open this up and use the functions here. So you can type in y equals negative x, and this a squared button will square whatever you're trying to square, plus 14x plus 51. So after you type it in, you might want to, it doesn't matter if you kind of move it over like that, or you can just open up the whole window. But I would, on my keypad, I have a MacBook, but even if you have a Chromebook, you would do the same thing. You can like shrink and like take your 2 fingers. I usually use my thumb and my middle finger together, make like a pinching thing, pinch with your 2 fingers, and then you can like zoom in and out. You can also click and drag like that. So I'm going to click it till we're right there. Now, what's cool about Desmos is that you can literally tap on the roots and it tells you the ordered pair. So one of them is -3, 0, and the other is 17, 0. And that's what I'm going to type in. So I'm going to come over here and type in -3, 0 and 17, 0. And again, all I did was click on the point. I clicked right there, and in gray, it shows me -3, 0 and 17, 0. Now for my vertex, I can do the same thing. I can hover over it, and it gives me the point 7, 100. And in fact, if they ask me for the y-intercept, I could hover over that point, and it tells me that the point is 0, 51. So Desmos is really awesome. So remember, your vertex is your max or min point. This is a max point, so the order pair is 7, 100. And that's all you're going to do for these. So I'm going to tab over and hit 100, or you can just click in the box. So 7, 100, and I'm going to submit my answer. All right, so why did it give me that? So if I look here, they want us to just type in the roots without writing it as an ordered pair. So I typed it in as an ordered pair because that was the expectation we did before, but clearly you're seeing now at this point, you only have to type in the actual x values, not the ordered pair. So I'm going to go back and do that again. Again, it was -3 and 17. And then again, my vertex was 7, 100. All right, and you're going to submit your answer. And I believe you have three, and I'll check real quick. So I believe you have 3 attempts. Yep, you have 3 attempts on every problem, so it's not going to be a big deal if you miss one the first time. So again, for roots, your instructions are to just put the x value from these x-intercepts, roots, zeros, and then state the vertex. But you will just need to open up a Desmos window and do it, okay? So please pause the video at this time and complete problems 2 and 3 the same way. All right, so hopefully you've completed numbers 2 and 3. We're going to go ahead and take a look at number 4. Here they are asking us to find the coordinates of the vertex of the following parabola using graphing technology. So they just want us to find the vertex. Now some of these may be in vertex form, and if they are, then that's easily identifiable, but sometimes they're not. So I'm just flip over to this window, and I'm just going to delete that and start over again. And this time I'm going to use my keyboard because I can. If I want to do an exponent, I need to hit Shift-6, then squared. But notice I'm still up in the exponent, so I need to hit the right arrow on my keyboard to make it come back down. But again, of course, you can use this keyboard here if you like as well, remembering that the a squared is how you would square x after you type x. So I'm asked to find the vertex, so this time my parabola opens up. One of the things you can do also after you've manipulated a window and you want to just reset it is hit this default zoom, and it'll send us right back here to like a smaller window. There is my vertex. So I'm going to hover over it, and it says 2, 9. So I'm going to type in the order pair 2, 9. All right, and that's it. Easy peasy, right? One thing I want you to remember is that we have an axis of symmetry that goes straight down here through the vertex at the equation x equals 2. That's going to come up in a few minutes as well. All right, so let's go ahead and pause the video at this time and complete 5 and 6 on your own. All right, so hopefully you've completed 5 and 6, and we're now going to move on to number 7. It says select the form to find a quadratic function or quadratic feature, in this case y-intercept. So if you'll take a look at what we have here, you actually have to do this through select form 19, okay? Select a form to see this. So I'm going to go to my notebook at this time to write down just a few notes. Nothing much, but more like so a reminder. So you might want to get out your graphic organizer that we use to take notes, or open up your notebooks. And this in particular, I'm talking about where we wrote standard form, vertex form, factored form. And just as a reminder, that standard form is y equals ax squared plus bx plus c, where the a value tells you if it opens up or down, and the constant term is your y-intercept. So I'm going to put y-intercept will be the point 0, c. If they ask us for the vertex, or anything coming from the vertex, like the max value or min value, so I'm going to put in our standard form. If they ask you for the y-intercept, you want to choose standard form. Vertex form is a times the quantity x minus h squared plus k, where again, a, if positive, opens up, negative opens down. But we want you to remember to switch keep, as in switch the sign of this number you see and keep the sign of this number, but your vertex is the order pair HK. So if they specifically state find the or what form would you use to find the vertex or the max or the min value? Or where is the graph increasing or where is the graph decreasing? Then you're going to use vertex form. And then we last talked about factored form. This can be written a few different ways. You can have an A, again, telling you the same thing if it opens up or down. But x minus root 1 and x minus root 2. Or, I've seen it lots of different ways. X minus p, x minus q, where p and q are roots. But what you will see is these two quantities in parentheses. So if they ask you for the roots, or, all those words that are synonymous, the zeros, the x-intercepts, then the form you would most like to see is factored form. Now remember, if they give you a different form, you can still find this information. I would just recommend using Desmos to do so, okay? But the nice thing is if it's in these three forms already, you can go ahead and find the answer. So I'm going to go ahead, pause that if needed to copy that down. When you submit a picture of your notes, this will be the first thing I should see, along with your date up at the top right. And actually, if you want at the top, title this Quadratic Review, since we're kind of reviewing all these concepts. And sometimes these questions are written a different way, and that's why we like them so good. Helps you to think about what we mean. So I'm going to go ahead and do number 7. So you are asked to select the form. It says a quadratic function is hidden from view, so you don't see the equation, but you must find the y-intercept and write it in the form xy. Choose the form of the quadratic equation you would most like to see in order to answer the question most efficiently. So again, if we want to see the y-intercept, look at your notes. If we want to know the y-intercept, we should be looking for standard form. Then they give us the function and ask us to answer something else. So what do we know? Are there no y-intercepts? Is there one y-intercept? Or are there two y-intercepts? Well, remember that from your notes, there will always only be one y-intercept. It can only hit the y-axis one time. It could hit the x-axis twice, or once, or not at all. But for y-intercepts, you're only ever going to have one. But if you needed to graph it to see it, you could certainly go over here to Desmos and type that in and see for yourself. So they are also asking for that intercept. Now, what are you supposed to remember from standard form about your constant term? If your constant term is 32, look at your notes. What did I say? I circled the plus C, and then I wrote the order pair 0C. So I'm going to type in 0, and then my C value, which is positive 32. If it was minus 32, I would put in negative 32 here. But it is positive, so I'm going to type in 32. And then submit my answer. Oh, I don't like the fact that it gave me those two parentheses. Make sure it only has one set, so it doesn't tell you your answer is wrong. And we are correct. Again, that constant term will always be your y-intercept. All right, so you're going to do the exact same thing here. Again, they are asking for the y-intercept, so let's go ahead and pause my video at this time, and your job is to answer actually questions 7 through 13. You should be able to go all the way down to 13. Here they're asking for max min. Actually, I'm going to go through one more with you. I'm going to go through this one. This is problem 9. I just had not added that to my list that I wrote down. So let's just do 9 because 7 and 8 are about y-intercept. 9 is about max or min. Actually, I have 4 of those, max, min. And then you got x-intercept, increase, decrease. But I'm going to teach about increase, decrease. So number 9 says a quadratic function is hidden from view. Really, you just need to go, okay, what is it I'm trying to find? You must find the max value. The max or minimum value come from what form? Look at your notes. They come from vertex form. So now I'm given an equation, a function here, and what is our max or min value? I want to say right here, instead of asking for the whole ordered pair, they're actually asking for the max or min value. So let me talk to you about that. So again, this is number 9, so put this in your notes. Your function was f of x equals -2 times the quantity x plus 3 squared plus 2. So write that down. And then I want you to identify your vertex. So our vertex, remember we switch the sign and then keep the sign, is -3, 2. But it's asking for the max value. So keep in mind, if it's negative, if our a value is negative, we know it opens down. Here, this value vertex for our vertex is -3, 2. So sketch that in your notes as well. If this is the case, which value, the x or the y, tells you how high something is? So I want you to keep in mind that max is how high, and your min, if they ask you for a minimum, it's how low. Well, the x doesn't tell you where, it tells you how high or low. It tells you where this point is. Like from the origin, we do have to go left 3. That does not tell us how high or something low something is. So your max or min will always be the y. Will always be the y from the vertex. Every time you are asked, what is the max? What is the min? Will always be the y from the vertex. So, in other words, I can look right here and just go, oh, that's the y from the vertex, so my max is 2. And that's correct. So see how they didn't want me to put the ordered pair? They wanted me to put the answer, the max value of the function is 2. It is the y value only. The y tells you how high or low because that's your up-down shift, okay? So that takes care of that. If they ask for the min again, so if it opens up because your parabola is positive, so right here, this time they ask you for, you must find the min value. That's going to be, again, the y from the vertex. The only difference is our a value is positive, so the graph opens up. So I'll make this shorter here. Y or f of x, it means the same thing. F of x, by the way, is just function notation for, and while y is just a simple form. Think function fancy, but f of x really just means y. So here my vertex is 2, -32. Again, I want, so the difference again is my a is positive, so that means this point is at 2, -32. So when it says what is the min value, what is the min value, I'm asking for how low is it. Well, this is my lowest y value, so my min is going to be -32. So I should see these two examples here in your notes. In fact, I should come over here and say max is 2. That way, when you're looking for max, min examples for when you're doing your test review, this is what you would want to look at. All right. So again, just as we did, opens up. the minimum or the lowest value is negative 32, which is our y value only. All right, so go ahead and pause the video at this time and finish 11 and 12. And then you should be able to pick up on x-intercepts. X-intercepts are also easy. So hopefully you paused the video and completed the next two problems. Now we are looking at problem 13. It says a quadratic function is hidden from view. You must find the x-intercepts. So what form are we going to use? Look at your notes. The x-intercepts come from a factored form. So now they give us the x-intercepts. If there are two factors, that means you're going to have two x-intercepts. I'm going to make the assumption that they want us to write these as an ordered pair. Remember, if you don't remember how to do this, you can always go to Desmos and type that in and just use y equals. But remember, you just set the factor equal to 0. So if you set x plus 3 equal to 0 and x minus 7 equal to 0 and solve for x, it's just going to give you the opposite. So it's going to give you negative 3 and positive 7. But remember, those values are the x values of the coordinate. Clearly, they don't need you to type in parentheses here. It looks like 7. No, they just need you to do 1. So if you just do one set of parentheses, you're good. All right, so negative 3, 0, and 7, 0. I'm going to submit. And that is correct. So if they ask you for roots, only give the x value. If they ask you for x-intercepts, make sure you write it as the ordered pair, okay? So you should be able to go ahead and pause the video at this time and do number 13. All right, so you should have 13 done. We're going to talk next about 14 and increase, decrease. So I'm going to flip my page for notes, and we are going to talk about what it means to increase or decrease. So for increasing and decreasing intervals, first thing I want you to understand that an interval is how we express a set of lower and upper limits. So intervals will always be in parentheses. This would be your lower. Just like we kind of think about domain and range, we put our lower number on the left and our highest number or higher number on the right. So maybe I should do lowest. Lowest, highest. These are the lowest and highest values that describe what is happening on an interval, and we're going to do increase, decrease. So first I want to talk about a parabola that opens up. One of the things I want you to understand is that while the ends of this parabola are only in quadrant 2, what's really going on is this thing again is going left and right forever. And I said left and right, but I went right. This is actually going right and up forever. And this one is going left and up forever. If we were to write an ordered pair to describe what quadrant this arrow ends up in, then this would be quadrant 1. In fact, the right side will always be quadrant 1. Doesn't matter if we have a wide parabola, that's going to end up in quadrant 1. If we have a skinny one, this one's going to end up in quadrant 1, and this one's going to end up in quadrant 2. So on the ends of these arrows, you're going to write what I call infinity ordered pairs. In quadrant 2, if it's opening up, in quadrant 2, this left arrow, the x value is towards negative infinity and the y value is towards positive infinity. Over here in quadrant 1, that's positive, positive. So this requires you to remember everything about like what the signs are in every quadrant. Oops, sorry. So this is positive, positive in quadrant 1, negative, positive in quadrant 2, negative, negative in quadrant 3, and positive, negative in quadrant 4. So these are the signs that correspond to your infinities depending on whether it opens up or down. So no matter where this parabola is, if it opens up, it's always going to be quadrants 1 and 2. So I'm going to write positive infinity, and then over here, negative infinity, positive infinity. Every time it opens up. Then I need my vertex. So let's say our vertex, since I drew this one in quadrant 3, let's say this vertex is negative 5, negative 2. That means that I went left 5, down 2. If I am writing an interval of increase, this is what we have to do, increase or decrease. First of all, I want you to think, let me trace my parabola from left to right. Every time, always left to right. In math, we always read graphs from left to right. So if I start up here on the left and draw or trace it, I'm going to go down, then up. Well, that means I'm first decreasing, then I am increasing from left to right. Okay, so you can't look at both sides and go, oh, they're both going up. You have to say the x values here. Okay, so for negative infinity, it's my y's here are decreasing, then increasing. So when I ask you for the decreasing or the increasing interval, you have to think, if I trace it, here I am decreasing, and on this side I am increasing. So write those arrows on your graph in your notes. The other thing I want you to do to make this super helpful is to always circle the x values. Just please circle them. Circle, 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 circle. Because when we write our decreasing and increasing intervals, we are only going to use x values. So every time we have interval, we use x only. We only use the x. We never look at the y. So because over here I went down first, this means it is decreasing from an x value of negative infinity to negative 5. So look how I have it circled. I'm going to completely ignore the numbers not in the circle. Only use the numbers in the circle. So it decreases from negative infinity to negative 5. And it increases from negative 5 to infinity. And that's it. It decreases from here to here. It increases from here to here. So write this down, because this would be our decreasing and increasing interval for this particular graph that I made up. Now, if we have a parabola that opens down, it doesn't matter if you see both and that's a really ugly parabola. You gotta forgive me. I was really only concerned about the ends. So these are ending up in quadrant 3 and quadrant 4. I don't care where it is. If it's here, it's still going to be quadrant 3, quadrant 4. So think back to what I did here. Let me make this bigger, I'm sorry. Think back to what I did here. If it ends in quadrant 3, it's going to be negative infinity to negative infinity. Please get in the habit of doing this. It's actually going to help you when you get to math 3 with a concept called end behavior. And then over here, my x's are going positive while my y's go negative. So this is quadrant 4, positive infinity, negative infinity. And again, just write your infinities according to what quadrant the ends end up in, okay? So again, if it opens up, it will always be quadrants 1 and 2. If it opens down, it will always be quadrants 3 and 4. So let's say this wonky parabola here has a vertex of 3, 9. Before I write my increasing and decreasing intervals, I am going to circle my x's. So this is what you need to do when you do these problems. You need to sketch it on paper, put these, and I want to see these in your notes for these particular problems that you're going to do. So after I have finished this, I'm going to do one with you on Desmos. I want you to pause the video and keep adding on to your notes, but I want you sketching it like I am, okay? So what does it do first? Again, trace it from left to right. So if I start on the left arrow, I have to go up before I can go down. So that means I am increasing, then decreasing. So increasing, decreasing. So if I'm finding the decreasing interval, it's decreasing from lowest to highest value. Don't go, oh, it decreases bottom to top. It decreases from 3 to x values of positive infinity. And we always use parentheses around these every single time. It increases from negative infinity to 3. If you do this, I promise you, I've been teaching for 20 years. If you do this, it will help you to get it right. Okay? And that's how we're going to write them. So let's go ahead to Desmos, and we're going to do this one next. It says a quadratic function is hidden. We want to find where it's increasing. Well, guys, what point did we use to be able to write our decreasing and increasing interval? We use the vertex. So that means we always want to use the vertex for increasing, decreasing intervals. So I'm going to come up here and say, need the vertex. In order to find an increasing, decreasing interval, we have to have the vertex. Excuse me. All right, so again, select form. We want vertex form. They give us the parabola, so this is where you got to kind of use your brain. So this is exactly what I want you to do. I'm sorry, let me go back and see what problem this was. This was 14. So that means in my notebook, I want you to put number 14, because I told you when you submit a picture of your notes, this is what I want to see. So again, we want vertex form. Write your equation, -3 times the quantity x plus 1 squared plus 12. And what do we know? We know that the vertex is -112, and it opens down because it's a negative a value. So you don't have to do anything fancy. I just want you to draw a vertex. Now the vertex is at -112, which is somewhere up here. So it's going to do something like that. No big deal, because we're still just going to write -infinity, because I'm in quadrant 3, and infinity, -infinity, because I'm in quadrant 4. Again, our vertex is -112, so remember you need to be labeling this. And then we're going to circle our x's so we don't mess it up. One of the most common mistakes I've had students make over the years is they use the y's. You never use the y's for any type of interval. So what does it do first? If I trace it from left to right, it increases, then decreases. Increase, decrease. So it increases from what to what? You've already circled it. -infinity to -1. And then it decreases from -1 to infinity. So if you're still struggling with this after you complete this assignment, or if you need to rewind it and rewatch it, then do that. I'm sure y'all watched a movie before, and the first time you watched the movie, you didn't catch everything, and then you watched it again, and you're like, oh wow, I didn't notice those parts. So remember that the second time you watch or the third time you watch, you're going to pick up on things more and more. So don't just watch it once and then be frustrated. Watch it a couple times till it makes sense. So now I'm going to come back here. Again, we want vertex form, and we want to know where it is increasing. All they're asking for is increasing. So look at your notebook, and we've got -infinity, comma, -1. And that's all they're asking for is the increasing interval. I have too many parentheses. So I'm going to go back. And it's correct. One of the things I want you to think of is if you're a person that can visually see it, like you're like, all right, it opens down. I'm always going to use the X from my vertex. I just need to switch that sign. If it opens down, then it's -infinity to -1. If it opens up, it's still, it would just be decreasing, right? Negative infinity, think about it like this over here on Desmos. This would be -infinity to this X value of 1. It decreases from -infinity to 1 and increases from 1 to infinity. So I think after you do a couple, it'll probably really sink in. All right. So that's increasing, and decreasing works the same way. So go ahead, pause the video at this time and complete through 19. Remember that you get 3 attempts at each of these. All right. For number 20, you have to determine whether it has a max or min. So if we take a look at this, what form is this? Oh, it's vertex form. So remember what we said about max or min. We always use the what? We always use the y from the vertex. So if I were, I'm just going to write this out on notebook paper. To remind you how to do these. But if this is my function, and I know it opens down, and my vertex is 5, 7, and I'm asked for the max or whether it has a max or min. Well, clearly, if it opens down, the highest point is this one, so it has a max. And what is our max value? Again, it's the y from the vertex. So the max value is 7. So what does that mean for a min? Well, you're going to have a min if what? The a value is positive, but the min value is still going to be the y right here. Okay, so submit, and I'm good. So just keep those things in mind. Again, but what's going to be interesting about these guys is, can we always see it from the form? Nope. So what form is this? This is in factored form. We do not see the vertex here. So what am I going to do? I'm going to go over to Desmos. And I'm going to type in -3 times the quantity x minus 9 times the quantity x minus 6. So if it's in vertex form and it's easily identifiable, awesome. That's the whole point of having a purpose for each different form. But if you're asked information but you can't see it from the equation, then we're going to need the graph. So if I want to know my max or min, well, let's look at it. Does it have a max or min? It opens down, so it has a max point. And what is my max? It's the y from the vertex. So I know that it is typed in right because I can compare my left and right windows. So my y value, again, was 6.75, so I'm going to type that in. Remember, we don't want it as an order pair. We just want the highest value, highest y. And that's correct. Okay, so that's what you're going to do for each of these types of problems. So like even on this one, this is in standard form, and we don't see a max in standard form, so we're going to need to type it in Desmos. So pause your video at this time and complete problems 1 through 26. All right, so you should have completed 1 through 26. So I'm going to do 27 and 28, and then you're going to do the last two on your own, and you'll be all through, and then need to submit a picture of your notes. So it says, what is the range of the function in the graph? So in your notes, please just put a quick reminder that your range is your lowest y to the highest y. Okay? So if we take a look at this, that means we really kind of need the vertex, don't we? If it opens down, so I'm going to sketch this in my notes, so you should too. Draw a parabola that opens down and put the vertex, which is at, from 0, 0, it's at 5, -1. So we've got a vertex at 5, -1. So please put this in your notes so that you can use this when you do your test review and your quiz on Monday. If range is lowest y to highest y, well, how low does this parabola go? It goes down forever. So my lowest y is -infinity. And we always remember use a parent for infinity. My highest y is right here, which is, what's my highest y? It's always the y value, not the x. So my highest y is -1, but I have to put a bracket around it. We put brackets around numbers and a parent around the infinity, whether it's -infinity or positive infinity. And that's my range. That's what I'm going to type in. So it's telling us, I want you to, right here, don't worry about this. You'll have intervals for all of these. And it's going to be, they tell you right here. I like that they have the option on these. So we're going to have a left parent on the left and a right bracket on the right. So I'm going to type that in. And then just hit, ooh, nice. They got -infinity here. And then I can just come over here and type the upper value, which is -1. So use this to help you out. And we're going to submit. And it's correct, okay? Because they give you a little explanation here, but it's exactly what I just gave you. All right, and then I'm going to 28. We're just about done finally. So what is the range of this function? We need our vertex. So what is our vertex? It is at -1, -4. So does it open up or down? Up, and up goes to y values of positive infinity. So my lowest y is right here at -4. So if my lowest is at -4, well, I should choose this for first. I always do bracket for a number, and my -4 is going to go first. I'm going to choose this one. If you want to write it on paper and then see what you would choose, that's fine. But then it goes up forever towards positive infinity. So my lowest is -4, and I put brackets on the numbers, and it goes up forever to infinity. All right, so you can go ahead and stop the video at this point and complete the last 2 problems, and you should be good to go. Then take a picture of everything that I wrote in my notebook. You should have written on yours, everything, to get full credit, and submit those with the link that's on the announcements. Good luck.